Hello everybody. In this video we're going to look at adding a different improved type of enemy. At the moment in our game we have an enemy here that's this little cog that is moving from side to side between these two blocks, or at least that is what it appears to be doing. When we designed this enemy, it had a specific path that it follows, so a distance that it moves, and we've placed two bricks or two blocks on either side to make it appear like it is bouncing. However, if we were to move or even remove these blocks, this enemy would still just move in the same spot because it's moving over a set distance. What we're going to try and do is create an enemy now that actually could sit on a platform, or in fact any area, and not fall off the edges. So if it was to come across here and detect this edge, it would turn around and move back the other way until it detects the next edge, and again just keep moving like that. So we could put it on top of any platform and it would be perfectly fine to move without falling off. So let's begin this process. We're going to start by creating a new scene for this enemy. So we're going to go new scene. It's also going to be a kinematic 2D so that we can have movement. It's going to need a child node of a sprite so we can see it, and also a child node of a collision shape. So let's set a few things. So we'll rename this one. I'm going to call it enemy blob. Now I'm calling it enemy blob because the sprite that I'm going to use is a blob style sprite that I got from the Kenny pack for platform games. So again, you can use any sprite you like, of course, but I'm using this blob. And the collision shape, in fact, I'm just going to zoom in a bit. I'm actually going to start by taking this sprite up and sort of putting it just on the center line. And the collision shape I'm going to add will be a rectangle, and again it's also going to be moved up, but it's just going to be big enough to detect the ground. So we're not going to be using this particular collision shape to detect other things colliding with this, such as the player or anything else like that. We're just going to use this to detect that it has landed on the ground or the platform so it doesn't fall through. So with that in mind, I'm going to rename this particular one to be collision ground, just to make it clear for myself. Okay, so that is the visuals of our sprite and its basic collision for the ground setup. It's now time to save this. So we're going to save this node. So, sorry, this scene, I should say, and I'll make sure I save that in my scenes folder. And we're also now going to attach a script. And again, I'm going to make sure I save that in my scripts folder so I keep everything nice and organized. If I went into my main scene now and I added one of these enemies in, so my enemy blob scene is here, you'll see it exists, but of course so far we haven't programmed it to do anything, so it just sits there like that. Let's now make it move. So the first thing we're going to do is require some variables, some things to actually get this going. So in our code, in our script file, we're going to add some values. Now these are similar to what we used for our player, for example. I've just copied them in. So we're going to have a speed that this blob can move at. I've decided on a speed of 100. We're going to have gravity in case it does need to drop down for some reason, and I'm using the same gravity at the moment that I've used for the player of 800. I'm creating a variable called val that's going to hold the velocity or the direction of movement for this character, this blob. And I'm also creating a variable called direction, which is going to be important in a moment. And it's going to have a value of either 1 or -1. And the reasons for that will become clearer in just a moment. But 1 is going to mean moving to the right. And if it's -1, it means it's moving to the left. So that's very important for us in just a second. Now we're going to uncomment the function process so that we can have it doing something each time. And we'll start by just adding some gravity. So let's go and put that in. Again, I'm just copying this from earlier. So my velocity in the y direction, so the y of course is the vertical direction, is going to be equal to gravity multiplied by delta. That means that we are going to be able to have this character fall down essentially if we need to. And then I'm also going to apply that velocity. So the next command in, where we move and slide, knowing that vector 2 up, of course, tells it that down, of course, is where gravity is going. So if we were to now play our game, we will see that that character dropped that little bit. We can see that a bit more clearly if I, in fact, take that blob and bring it up nice and high. If I press play, we will see the character does fall and it is working with gravity. It's stopped on the block. So that is a good step so far. Moving on, if we now want to make our character move to the right, we're going to add some velocity in the x direction. So x, of course, is the horizontal component of this velocity. So I'm going to add that in now. And our velocity in the x direction is going to be equal to our speed value, in this case 100, multiplied by the direction. And this is where that 1 or -1 comes in. So by default, if you looked at our sprite is facing to the right, so there's the eye to the right. So moving it to the right means a x direction that is increasing. So in Godot, we move to the right with a positive x or an increasing x. And if we move to the left, we have a negative or decreasing x. So by having our speed value multiplied by either 1 to move to the right, we'll get a positive value. Or if we multiply speed by -1, we'll move to the left. Okay, now we're also going to multiply that by delta just to make sure that that works nicely. So if we press play now, we should see our character start to move. Now it is going very, very slowly. In actual fact, I don't think I need to include delta at the moment. Let's just go back and see. If I take delta out, do we get an improvement in movement? Yes, we do. We are falling off the platform. It's not what we want yet, but it is an improvement. So let's leave delta out for a moment. We might come back and investigate that in a moment. What do we need to do now? Okay, so we have a situation where, if we look at our main scene for a second, the character can move, but of course you saw it fell off. It needs a way to detect that it's come to the edge and not do that. In fact, turn around and move the other way. So the way we're going to do that is introducing something new that we haven't seen, at least we haven't seen in the order that I've been doing these videos, and that is something called a raycast. So let's go back to our enemy, our blob enemy, and we're going to add in 2 new things called raycast 2Ds. Now I'm only going to add one to begin with, and I'll explain why. Simply I'm going to set it up the way I want, and then I'm going to duplicate it so that it saves a bit of work. So this is going to be my right hand side raycast. Now what a raycast does, it's like putting out a little feeler, if you like. It is basically looking at this point down here and saying, hey, am I hitting something or not? So you can use it to sort of work out if you're going to or you are touching something around you, basically. Now what I'm going to have in the end is 1 here for the right hand side and 1 here for the left hand side. And when they go off of the platform that it is sitting on at the moment, it'll say, hey, that's the edge. And then essentially we'll be able to turn our character around and go back the other way until that side's raycast or feeler detects the edge and then basically turn around and come back again. So because this is going to be on the right hand side of my character, I'm going to just rename this to raycast right just to differentiate the two. And let's have a look at how we make this work. So if I go into my script now, what I'm going to do is ask a question. So I'm simply going to say is, and I'll do this just underneath here. So I'll copy that code that I've already got to the side here and bring it in for you, just to save some typing. So I'm basically saying if not, if it's not the raycast colliding, so raycast 2D right, sorry, I copied and pasted this, so I did change the name slightly. Let's fix that up. Raycast right, that's the name I've used this time. So if the raycast is colliding is not true, basically, we're going to change our direction variable to be equal to -1. So this means we have reached the edge of the platform on the right-hand side. So now we want our direction to be the opposite, so to the left, and we've said that's going to mean -1. And we're also going to flip horizontally our sprite. So again, the sprite will flip around so that it looks like it's facing to the right as well. Now, I want to do all of this again on the left-hand side. So the easiest way to do that now is we're going to duplicate this raycast. We will call this one left, and then in the code, we're going to also duplicate this if statement to say, hey, let's check the left-hand side. All right, so the left raycast. And if it is not colliding anymore, this will become a 1 because we want to now face in the right-hand direction. And we will unflip the sprite so that we can face the right as well. So let's have a look at that in our what am I trying to say? in our main scene first, sorry. So if we go to 2D, so I've got a problem. I haven't moved my second raycast. So let's put this back here for a second. Go back to our enemy and let's make sure we've got the left cast and drag that across. Sorry, I've got to grab the little XY square thing here and move that over there. So that's now got a left hand and a right hand one. And actually there's one more thing I just remembered that I didn't do. And it's a little bit of a strange thing, but raycasts by default, if you look over here in the inspector, are not enabled or turned on. So you can see they're grey until you turn them on. So that's kind of important, otherwise the raycast itself won't work. So now if we go back to our main scene after saving and have a look, there is our raycasts. Now if I was to start this with my blob up in the screen like that, because they would not be touching, so there's the point that they're trying to touch, it would get all very confused and probably bounce around quite a bit. So I'm going to bring it down lower. Now the other thing I just want to check is if I bring this down to where it's going to sit, which is roughly here, I want to make sure my raycasts aren't sticking out the bottom, for example. And just to be safe, it might be worth adjusting those raycasts a little bit to make them a tiny bit shorter. So I'm going to go back to my blob. I'm going to go to my raycast and I'm going to look first of all at the cast to. So this is the direction that we're trying to cast to. So we're not casting any direction on the X, we're just casting straight down on the Y. I'm just going to make those 25, half the size they are at the moment, just to make sure there's no chance that they're going to stick out the other side or the bottom of the platform. Okay, with all of this done, let's try our game again and have a look. And there you go, that seems to be working quite nicely. So our character's moving across, the raycast just sticks out the other side, says, hey, I'm not touching anymore, so turn around and go back the other way, and off we go. Now, we haven't done anything about this character hurting or doing anything to our player, because we do have that tiny little collision shape there. That's why my character's actually riding the guy at the moment. It's also why if I get in its way, it will actually stop, because that collision shape is saying, hey, stop, just like it would with any other object. And of course you can fix that, and you can also go and have a look at how would you add something to our blob to actually injure our character the same as this one over here does, that gear. That's something you can have a look at for yourself. But for now, the focus of this particular video was how do we get this this enemy to move on a platform so that it can't fall off without having to put blocks in the way or invisible barriers or anything like that. So that will work for us. Just out of curiosity, let's chuck a couple more of them in there. So if we duplicate this blob now and put one of them maybe on this platform here, and just for fun, let's see what it looks like if we put it on a single block. Now the main thing here is that the raycasts can't go off the edge yet, so let's just put it right in the middle there and have a little look see at what it does. So it is working. Oh, we seem to have lost one over there. I think I moved that by accident. Let's check, where are they? Enemy. There's one there. There's one there. Where did number 3 go? Actually, is it stuck? Oh, it's over there. So let's put that one on here instead. So if we play, yep, so there we go. So it is working. It doesn't have far to move, so it seems like it's just bouncing around, but it is technically finding the edge, coming back the other way, finding the edge, and so forth. So there you go. That is a way to use raycasts to help you find something such as an edge. There are other things, of course, you can do with raycasts to find out if something's in front of you, behind you, above you, all sorts of things. But there's a very basic introduction to raycasts and an example of how we can create something that is moving on our platforms. Now, as always, if you're in one of my classes, feel free to ask for some help with this or any other part of your game development. If you're not from my class, then of course you are, I hope that this has in some way helped you with your programming and game development experience. Thank you very much for your patience and for watching this video.